Good morning, students. So today we are going to discuss next portion of our third unit. It contains electron gain enthalpy and electronegativity and their variation in periodic table and the factors on which electron gain enthalpy value depends. Okay. So let us start first with electron gain enthalpy. So it is just the reverse of ionization enthalpy. So in electron gain enthalpy, what happens? In electron gain enthalpy, we take a particular atom in its isolated gaseous state and then we add an electron in this and then there is formation of negative ion. Now during this process, whatever heat is lost or gained, that is known as electron gain enthalpy. So since it can gain also, it can lose also energy, so the reaction may be exothermic also or it may be endothermic also. Okay. Now what will be the definition? We will say that it is the heat change during the addition of electron in an atom in its isolated gaseous state. Okay. Now if we talk about halogens, okay, in case of halogens, the valence shell electronic configuration is ns2np5. So what does it mean? It means there is a requirement of only one electron to become more stable, okay, to acquire noble gas configuration. So it means that gain of an electron will be easiest in this case. Why it will be easiest? Because after gaining an electron, it will come in noble gas configuration and it will become most stable. So what we will find? We will find that in case of halogens, addition is easiest. If addition is easiest, then it means delta H Eg values will be highly negative. Highly negative means that value of heat evolved will be maximum. Okay. So in this case we find that halogens have maximum value of delta Heg, maximum negative value. Similarly, if we talk about noble gases, now in case of noble gases, the valence shell electronic configuration is ns2np6, which means that they have fully filled orbitals. Now since they have fully filled orbitals, so they do not require any electron. So if we have to add an electron, then energy is to be given. So energy is to be given means delta H Eg value will be positive. So what we will say, that in case of noble gases, they do not want to add any electron in themselves, so they will have highly positive values of electron gain enthalpy. Okay. So now what we concluded? We concluded that if addition of electron is difficult in some case, then it means the delta H Eg value will be highly, this value will be highly positive. And in case addition of electron is easier, then delta H Eg value will be highly negative. Okay. Now what are the different factors on which electron gain enthalpy value depends? So electron gain enthalpy value depends on atomic size, it depends on effective nuclear charge, and it depends on exceptional electronic configurations. So first is atomic size. With the increase in size, the attractive force decreases. Okay, with the increase in size, attractive force decreases. It means addition will become difficult. So it means if addition is difficult, then the value will be either positive or it will be very less value, very less negative value. Okay, because of increased size. Okay. Now let us come to second is effective nuclear charge. Okay. Now we know that what is the purpose of nuclear charge? Nuclear charge attracts the electrons towards itself. Okay. So if we have two particular atoms, out of which one has higher nuclear charge and another has lower nuclear charge, then attractive force will be more in case of having, in case of atom, having higher nuclear charge. So it means in that case addition will be easier, and easier addition means electron gain enthalpy value will be higher. Okay, so it means with the increase in effective nuclear charge, delta H Eg value also increases, it becomes highly negative. Now third is exceptional electronic configuration. Now see, we know that fully filled and half filled orbitals, they possess extra stability. So if they are stable, then they will not allow addition of further electrons. Now since they do not want to add any other electron in themselves, so it will be difficult. It will be difficult means electron gain enthalpy value will be either positive or it will be very less negative. Okay. Now how delta H Eg value varies in group or in a period. Now see, when we talk about group, then what happens in a group? When we move from top to bottom, size increases. What happens? Size increases. Increase of size means attractive forces decrease. If attractive forces decrease, then it means addition of electron will be difficult. Now since electron addition is difficult, so what does it mean? It means delta H Eg value decreases as we move from top to bottom in a group. Okay. Now when we talk about period, then we have to move from left to right, and left to right what happens? Size decreases. Size decreases. Now if size decreases, then what happens? Then attractive force also decreases. No, attractive force increases, because with the decrease in size, attractive force has to increase because nucleus is nearer to the outermost electrons. Okay. Now since attractive force is more, so it means if you want to add an electron, then it will be easier. Okay. Now if addition is easier, then it means delta H Eg value will be more. Okay. So this way delta H Eg value varies in the group and period. Now second property. Second property is electronegativity. Now what is electronegativity? In simple words, what we can say? We can say it is the attractive force of the bonded atoms. When certain atom is bonded with any other atom, then the force or the power with which an atom can attract the shared pair of electron towards itself. Okay, that is called electronegativity, or in other words we can say it is the attractive power of an atom when it is bonded with any other atom. Okay, so here in which way it is defined? Here it is said a qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself is called electronegativity. Okay, so what is electronegativity? It is the force with which, or it is the ability of an atom to attract the shared pair of electrons towards itself. Okay, now what are the different factors which affect the magnitude of electronegativity? The different factors which affect the magnitude of electronegativity are atomic radius, effective nuclear charge, oxidation state of the atom, and hybridization state of an atom. Okay, now here two things we have done till now. Other two things we will be doing in next chapters. So with atomic radius and effective nuclear charge, how it varies, this is what we have discussed now also. With the increase in size, what will happen? The distance of nucleus from the outermost electrons will be more. So if this distance is more, then it means the attractive force will be less. Okay, so if attractive force is less, then we will say that electronegativity value will be less. So electronegativity value decreases with increase in atomic radius. Okay, similarly effective nuclear charge. Effective nuclear charge if increases, then attractive force increases. So electrons can be pulled towards itself by more power. So it means electronegativity value will increase. Okay, so what we can say, with the increase in atomic radius, electronegativity value decreases, and with the increase in effective nuclear charge, electronegativity value increases. Okay, now how it varies in a period and in a group. If we move in a period, okay, then electronegativity value will increase. Why it is increasing? It is increasing because when we move in a period, then what happens? Then size decreases. Because of decrease in size, the attractive force increases. So addition, or not addition, here we are saying about attraction. So attraction of the atom towards electrons, that also increases. So it means electronegativity value will increase when we move in a period from left to right. Now if we move in a group from top to bottom, then electronegativity value will decrease. Why it will decrease? Because here size increases. Just now we did two factors. So size when increases, then attractive force becomes less, and since attractive force becomes less, so what is the result? Electronegativity value will decrease down the group. Okay, now see in this picture you can see all the properties and their trends towards the arrow. This shows the increasing nature. Okay, now see this way, the direction is like this. It means ionization enthalpy as well as electron gain enthalpy increases when we move from left to right. Similarly here you can see, if we move from bottom to upside, then ionization enthalpy and electron gain enthalpy values increase. Okay, if we move from this side to this side, then atomic radius increases. If we move in the reverse case, then electronegativity increases. Okay, so this is just to remind you about all the properties which we have discussed. Okay, now whatever we have discussed, on the basis of that you have to complete these home assignments. Okay, thank you.